Hi guys, we're going to start with a pretty simple problem for heat on page 220. It's problem number 8. The problem reads, urea, NH2,2CO, is used in the manufacture of resins and glues. When 5 grams of urea is dissolved in 250 milliliters of water at 30 degrees Celsius in a coffee cup calorimeter, 27.6 kilojoules is absorbed. It's given that the density of water is 1 gram per milliliter. Part A asks if the solution in process is exothermic. For Part B, we need to find Q of H2O. Part C is asking for the final temperature of the solution, and Part D asks what are the initial and final temperatures in degrees Fahrenheit. We'll start with Part A, when we need to find out if the solution process is exothermic. We know from the information that is given that during the entire process, 27.6 kilojoules of energy are absorbed. And we know that if Q is positive, that means the solution is endothermic. So in this case, the process is not exothermic, but rather it is endothermic because Q is positive. For Part B, we're asked what the Q of H2O is. Again, back to the information that is given to us, we know that 27.6 kilojoules of energy are absorbed are absorbed during the whole process. And we know that this energy, the energy that is absorbed after the solution is combined, must be gained from somewhere. Now, this energy we know is gained from the water. So, if 27.6 kilojoules of energy is absorbed by the end of the process, that must mean that during the entire process, the H2O releases 27.6 kilojoules of energy. So the Q of H2O is negative 27.6 kilojoules. For Part C of the problem, we're asked to find the final temperature of solution. To start, just think back to the equation Q equals mc delta T. Once we plug in our givens, we get 27,600 equals 250 times 4.18 times temperature final minus 30. Don't forget to convert 27.6 kilojoules to joules, because C, your specific heat capacity, is a unit that is given in joules. 250 is the mass of the water, as we are given 250 milliliters of water, and the density of water is 1 gram per milliliter. 4.18 is the specific heat of water, and for your change in temperature, because we're not given the final temperature, but we are given the initial temperature, you can rewrite delta T as temperature final minus 30. Once you simplify this equation using some simple algebra, the answer to the problem is temperature final equals 3.6 degrees Celsius. The final part of the problem asks us to find the initial and final temperatures in degrees Fahrenheit. To convert from Celsius to Fahrenheit, all you do is multiply the temperature of Celsius by 9/5 and then add 32. So, for our initial temperature of 30 degrees, multiply 30 by 9/5 and add 32 to get 86 degrees Fahrenheit. And for our final temperature, which we solved in Part C, multiply 3.6 times 9/5 and add 32 to get 38.5 degrees Fahrenheit. All right, thanks guys, hope this helps.